Hi all, good afternoon. We explored the syntax of a simple inheritance in the last session. Can anyone tell me the syntax for a simple inheritance in Java? Yes, how to define a simple inheritance in Java?
Class name, extends,
Yes.
superclass name.
Okay, then you need to define the additional members of the subclass. Base class to derived class in C++ becomes here the superclass to subclass relationship in Java. And inheritance of 2.java, right? I think they have asked for so many queries, right? Those queries are right. I have clearly explained in inheritance of 3.java code. You might have seen that code. Inheritance 3.java. Again, right? I explained the code. In this example, right? Even in example, inheritance of 2.java, we are trying to focus on only this concept. How a superclass variable can assign or can reference or can point a subclass object because this is the important concept to achieve runtime polymorphism in Java. So this is illustrated in this example. In this example, right, we do not want to introduce method overriding concept because after this example, right, we are going to explore the uses of super keyword, how the instance variable are hidden with respect to inheritance, and how the instance variable hiding is resolved with the help of super keyword, and how to write resolve the overridden methods with respect to a super class and using a super keyword, right? And then we focus on how multi-level inheritance is implemented in Java, then method overriding, and then we will focus on the runtime polymorphism concept. So as of now, right, just to think of the relationship between a superclass and a subclass. Superclass can have its own object, subclass can have its own object. Superclass members can be accessible using the superclass object independently, right? As usual, no problem. Subclass object, right, can have the rights to call the corresponding superclass methods which are inherited with respect to the public. In this example, right, let us have right two classes. One is a class square and another one is a rectangle. The class square defines some instance variables cmpx comma area. And the one argument constructor is defined, right, square mpa x is equal to a. Then its own method, say compute area corresponding to the class square is defined. Area is computed and the value of area is printed within this compute area square method. Then we would like to define that is extend a new class called rectangle, which is extended from a superclass called square. Square is a superclass, rectangle is a subclass. Square, which is a superclass, and a rectangle, this is a subclass. Subclass additional members are defined here. For example, all these highlighted instance variables under methods, simply members of class square, are once again available in the class rectangle. So for example, to compute the area of a rectangle, we need two instance variables, x and y. Since the square, right, already defined one instance variable x, right? Additionally defined the requirement of a new class rectangle. Rectangle hence it takes one more additional variable into y. For example, x holds the value of length and y holds the value of breadth. We can compute the areas equal to length into breadth. And x and y are the instance variables of class rectangle. And since x is inherited from square, we can access the variable x inside rectangle because x is of the public access group. Then rectangle class, to initialize the object of rectangle class constructor is defined here. Then the class rectangle defines its own area computation. Say area is equal to length into breadth x into y, and the area is printed in the class, sorry, in the method rectangle. So square is a superclass, rectangle is a subclass, additional members of class rectangle is defined here. Then this highlighted version is once again available in the class rectangle because of simple inheritance rule. Now coming to the main method, say inheritance 3, we have created independent objects for super and subclasses. Square S1 is equal to mu square of 5 is the actual parameter. So that the object S1 is constructed. S1's the instance variable X is initialized to 5. S1 dot compute area square. Now we can see the result. The area of a square is, right, say 5 into 5, 25, and 25 is 20. Then independent of the class rectangle, right, one object R1 is created. Rectangle R1 is equal to new rectangle. R1 dot compute area of rectangle. So R1's X and Y are initialized, but actually X is inherited from the class square. R1's X is initialized to 50 and R1's Y is initialized to 25. Then R1 dot compute area of rectangle using the object R1, you are calling its own method, that is additional method of a class rectangle. However, in which area is computed using X star Y. X is actual instance variable of a superclass. Y is the instance variable of its own class, right? Rectangle class. And the area is printed here. So here you can see the message, say 50 into 25, right? The area of rectangle is computed. Now, before going to see, right, superclass reference variable to subclass object, this is also supported in Java, right? S1 is equal to R1. What is R1? R1 is a rectangle class object. S1 is the superclass object, square object. You can assign the subclass object to a superclass object. So assigning a subclass object to a superclass object, you should know that what is actually pointed in S1. How S1 is affected after this assignment statement, S1 is equal to R1. So to verify that, right, I have printed the contents of S1 dot X and R1 dot X. Since R1 is assigned to S1, right, no copy of the object R1. Instead, as we discussed earlier, right, R1's X content and S1's X content are binding the same memory location, right? So R1 is assigned to S1 in the sense that now S1's X, what will be the value of S1 dot X? What is the value of S1 dot X in this line?
So
S1 dot X is
50.
very good. S1 dot X is not 5. Previously it was 5. S1 dot X is 5 here. But after this assignment statement S1 is equal to R1, only the superclass instance variables can assign value from the subclass object. So understand clearly here S1 dot X is 50 and ultimately R1 dot X is already 50. But you cannot access S1 dot Y. That is very important because Y is actual instance, Y is yes, actual instance variable of a class rectangle. Using superclass object, you cannot reference the additional members of a subclass. Hope you understand. Using the object of a superclass or even reference variable of a superclass, you cannot point to any additional members of the subclass. So S1 dot
So your voice is not audible, sir.
1 minute. So using the object S1, S1 dot Y is invalid. S1 dot compute area underscore rectangle, this is invalid because these are the additional members of a class rectangle. So understand clearly S1 dot Y, this is inaccessible here, and S1 dot, right, the method compute rect method, that is an invalid one. Now we are setting, right, I want to check, right, what will happen if R1 dot X is changed. Will it be reflected in a variable S1? Yes. If you want to change R1 dot X to 100 and printing the value of S1 dot X, what will be pointed in S1 dot X? S1 dot x is
100.
100. Very good.
100.
100.
Yeah. Then we are changing from S1 dot x. Then say changing S1 dot x to 50. Then this will be reflected in a variable R1 dot x. Now R1 dot x is retained, right? The same value 50, which is again available in S1 dot x. So just to think of x is a common memory location to the objects S1 and R1. Now consider how a superclass reference variable is constructed. We have already seen that a reference variable for a class is constructed using class name space reference variable semicolon. So square is the superclass space. Let us have sref, right? Some reference variable sref semicolon. Then subsequently sref can point any of its subclass object. This is a rule. Or even these two statements can be combined into a single step square sref and constructing a reference variable, right? Sref at the same time, sref can point any of its subclass object. So R1 is the subclass object of square class. Square sref semicolon. Sref is equal to R1 as in a simple statement. Square sref is equal to R1. This is value. The meaning is superclass reference variable is actually pointing the subclass object. Just to recall in C++, right, a nice concept you might have studied in virtual functions under runtime polymorphism. Base class object pointer, derived class object. Base class object pointer can have the rights to point the address of not one. What is a pointer?
Derived class.
Address of a derived class object. Pointer is a variable which can point to the address of some other variable in the system memory. Base class object pointer, right? Base, for example, star, bptr, base class object pointer. Derived class, you can create object, right? Since it is an object pointer can point to the address of some other objects in the system memory. So base class object pointer, say base pointer p can point address of d, assuming that d is a derived class object, right? So in the same way here, do not confuse the pointers concept here. Superclass, right? Here we are creating just a reference variable. That reference variable can be directly assigned to the object of the subclass. So in this, right, you need to explore what is actually pointed by sref. What can be accessible using the reference variable sref. That is important. So what is actually pointed in sref is equal to R1. This is important. In case we do want to print the value sref.x and r1.x, I think r1.x is retained the value, right? Same 50. R1.x is 50, R1.y is 25. So recall that R1.x is 50. Where are we here? Okay. Here. R1.x is 50, right? So in this assignment statement, sref is equal to R1, sref.x prints here, yes, sorry, sref.x prints what value?
50.
50, 50, sir.
50. Since r1.x is currently 50, sref.x is 50. As we discussed earlier, superclass object is equal to subclass object. Superclass object, after that, can have the rights to call only its own members. However, the updated values of subclass object can be assigned to them. In the same way, setting sref.x is equal to 100 means, right? Here, after that, checking r1.x, r1.x is updated to 100. Setting r1.x is equal to 50 means this is automatically reflecting in sref.x because currently sref is a reference variable. That reference variable is pointing an object, right? So sref.method name that is valid if and only if that instance variable our method must be a method of the superclass. Otherwise, the same method, right, must be redefined in the subclass with respect to overriding concept, right? So later we are going to explore what is method overriding. So here, right, R1 dot X is again, right, set to 50. So clearly in this statement, sref dot X is 50, R1 dot X is 50. As we discussed earlier, sref dot Y cannot be accessible because Y is actual instance variable of rectangle class. Using a superclass reference variable, we cannot point any additional members of the subclass. This is a rule. sref cannot access any additional members of Y or any additional members in the class rectangle. Say sref dot compute area rectangle. This is invalid one. That's what even right in the last session, right, I focused. For example, the first class, superclass reference variable dot one method is given, right? That method is actually a method available in the superclass. But when we also reference variable sref is pointing a subclass object, you can't say that is the actual method of a superclass. Since in case if you have redefined the version in the subclass, the subclass version is actually called. So that's what there I have said the superclass reference variable dot method name is actually pointing to a method of the subclass provided that we are not implemented the method overriding concept. So it seems that actually, right, as some of you have raised, why again the superclass method is called not in the subclass. That is the reason. Because no method overriding is implemented in the example. So sref cannot access additional members of the class subclass rectangle. This is important. So what is actually pointed by or accessed using sref means sref can access only its own members. Its own members in the sense that the superclass members. Suppose the same superclass members are redefined in the subclass. That is a concept of instance variable overriding or method overriding. So that stage, right, we have said that same concept. sref dot the method which is available in the superclass actually calling a method available in the subclass. That is a logic. So sref dot compute area of square, right? The same concept that we are now explaining. sref dot compute area of square. Since sref is the reference variable of the superclass and sref is currently pointing the object R1, but compute area underscore square. This is actual method of a class rectangle. But in the class rectangle, we are not redefined compute area underscore square. So it seems that as we have said, we are calling only the superclass method. We are not calling the subclass method, right? So that's exactly true. Because it's just to think of compute area underscore square. This version is available in the class rectangle. That's what the version which is available in the class rectangle is called. Even it seems that no overriding concept. In case if we have redefined the same method inside the class rectangle, the actual version available in the rectangle is going to be called. Right? Actually, the subclass version is going to be called using superclass reference variable dot method name. If and only if, right, the method is redefined in the subclass. Right? If not, right, it seems that no method overriding, a superclass
So
version is
can
going
we
to be called.
so can we call
Yes.
overriding methods in the subclass with the objects of the superclass, sir, without creating a reference
Yes.
variable and assigning the object of the superclass to the object of the subclass? Can we access the method overriding with the object of this superclass, sir?
Let us check, right? Actually, right, in Java, superclass reference variable is enough to achieve runtime polymorphism. I didn't check that, right, using superclass object, right, to call the overridden version of a subclass. We will check it. So in this line, sref.compute area underscore square, this calls the actual version available in the subclass, right? But in subclass, no overridden version is defined. So here sref.x is 50 because of this assignment. Sref is equal to R1, right? Of course, right here we have changed sref dot x and r1 dot x. Anyhow, right, even without these changes, here sref is pointing r1 means r1 dot x is 50. So sref dot x is 50, but understand clearly the square version which is available in the superclass is called here, no method overriding. So the value of x is taken as 50, right? So 50 into 50, right? 2500. The area, right, is treated as area is equal to 2500. So sref.compute area underscore square. This actually calls the version of the class rectangle. That's what in the previous example I have said that the method is actually calling the version available in the class subclass, but it seems that no method overriding. So we can assume that the actual version of superclass is called, right? But anyhow, the instance variables are right assigned the updated value because of the R1 object X is assigned to SREX is X content. That's what here it seems. Area is 2500, right? So the logical concept is superclass variable, superclass reference variable can point the corresponding subclass object, any of its subclass object. This is the primary concept which is used to implement the dynamic method dispatch, also called late binding or runtime polymorphism in Java. Hope you understand how a superclass reference variable is pointing, assigning, right, the corresponding subclass object. Having any queries in this example? Okay, I move on to the next example. In this example, I will like to focus on the usage of super keyboard. Like this static final, super is also a keyword available in Java. The purpose of super keyword is to initialize the superclass instance variables. From the subclass constructor, you can go for initializing the instance variables of the superclass. Have you remember the way of passing initial values from the derived class constructor to the superclass constructor?
Yes, sir. In inheritance, when we are using the, if we are inheriting the other, then we can use the parameterized constructor for initializing the values.
How is it possible in the derived class?
Sir, we can initializer list, sir, through initializer list.
For example, class A, class B is a derived class. In class B, right, formally I write here, it's also recall, even C++, it's a good language. Class A, I formally write here, class B, scope, sorry, what one, this one,
Public,
colon,
public.
right, after that what you have to do, say public, good. Public, then A, after that,
After that,
class,
next curly bracket, sir.
Card readiness
good.
statement.
Yeah, class B is going to be defined. Then B class constructor, remember that, for example, B of int x comma y, int x comma int y. Then, assuming that the class A is taking one constructor. Actually, constructors are defined in the public section, right? So here, right, assume public label.
Yes, sir.
Here also, right? Okay. So here one constructor is defined, B colon, something, right, one integer variable, suppose x, assuming, right, I don't want to miss the definition. Okay. Here, whenever you are creating the object of a class B, you need to pass some initializer to the base class. So that stage, what you have to do means, colon, next what you have to do,
A of x.
A of x or y, whichever is right, x or y. We can write, for example, how to write it. A of x or y something we will be writing here like this. So the value of variable y is passed as a parameter to the base class constructor, right, in C++. In the same way, right, in Java, we can introduce a super keyboard from the subclass constructor so that required initialization may be permitted to initialize the instance variables of a superclass. This is the purpose of one possible usage of super keyword. For example, the syntax is super parameter list. Say super x comma y comma z or super pi comma 3. So in this stage, right, the constructor, subclass constructor must have super executable statement as the first statement in its definition. Clear? Clear or not? Superclass constructor is there, subclass constructor is there. In the subclass constructor definition, this statement, super argument plus semicolon, should be used as the first executable statement. So the restriction of a super statement in the subclass constructor is it must be the first executable statement, right, in the subclass constructor. To try to see this example, you will understand. Class circle class instance variables, right, are declared here. Circle class constructor. Then one method is defined, area computation. I have defined one argument constructor and one display method is defined. So with this circle class is over. Remember one parameterized constructor. And in the class rectangle, rectangle extends circle. So in what way, right, we are extending means, right, a circle is having, right, one parameter, say radius. But here in rectangle, two parameters are required. Of course, we can say instance variable optimization. Same variable can be reused inside the class rectangle. So only, right, one variable is additionally defined, say float R. Then inside the class rectangle, in case if you pass only one parameter, right? One parameter float x means I do want to pass, right, that parameter to the superclass constructor. I have to use super as the first executable statement, a super of x. Having any queries in this? Super of x means this is a super statement that is used as the first executable statement in the subclass constructor. So the value of x is used to initialize the superclass instance variable. Superclass instance variable, right, is initialized using this one argument constructor. The same value of x is received in the variable z here. Z is further used to initialize the variable q. Q can be accessible inside the class rectangle to find out the area, say Q into R. Already a Q is defined there, R is additionally defined. So let it be area is equal to length into breadth. Area is equal to Q into R. In case when we construct a rectangle class object with two parameters, one is for length and another one is for breadth. Rectangle, a float x comma float y. Assuming that one variable is used to initialize length and another one is used to initialize breadth. For example, length is in the superclass and breadth is additionally in the subclass. Using x, we need to initialize a variable q. So just to call super of x. What is x? X is one formal parameter. The formal parameter is passed as a parameter to the superclass constructor. Super of x means how many arguments we have mentioned? One argument. So one argument superclass constructor is called. This is the one argument superclass constructor. There the variable, instance variable, q is initialized to z, right? A q is actually getting the value of a variable x. Then the additional variable, right? Say r is receiving the local parameter y. R is equal to y. So that r and q are used to compute the area of a class rectangle. Here, the important thing is, right, these are the executable statements in which the super statement it must be the first executable statement of a subclass constructor in case if it is defined. In case the super of x is not defined, no problem. You cannot use super of x even after the println statement. That results in error, compile time error, because the println statement may introduce the updated value of a variable, right? Superclass instance variable. So for that purpose, it is expected that before making any computation as the first executable statement, it is a good practice to initialize the superclass instance variable, and also this is a mandatory one. Super statement is introduced means it must be the first executable statement inside the subclass constructor. Then inside the main method, we have created an object of circle. Circle class methods are called independently. Rectangle class object, rectangle class compute rect and display are called compute rect and display. So here write 2.5 f comma 0.9 f. Superclass from superclass instance variable, right? 2.5 is initialized. In what order, right? The constructors are called means parameterized constructor of rectangle class is first input. That you need to check it right here. Rectangle say float x comma float y. System dot out dot println. First I have given the message superclass constructor call. So after this right, you can see the assignment statement r is equal to y. Here if you print system dot out dot println after r is equal to y or after the super statement, right? So it seems that first the superclass super of x without executing further statements in the subclass constructor, control transfers to execute the complete version of the superclass constructor. Then it comes back, right, to execute the next sequential statements. So likewise here R2 object is constructed by passing one parameter. So 5.0 is initialized to both the length and the breadth instance variables. Then its area is computed and the value is input. Let us check the code. Java C inheritance code.java. Java inheritance code. First the area is printed, then right from the subclass constructor definition, we have provided the message, right? Superclass constructor is called, but you try to give the message, right? Superclass constructor is called back here. Try to give the message superclass. For example, let me modify the code. Back to give here.
Sir,
Superclass
when we are
constructor.
calling the constructor for the rectangle class, the execution of the superclass constructor will be first, no, sir?
Yeah, inside the rectangle class constructor, if you introduce a super statement, then a super class constructor is called first. Then a subclass constructor is executed sequentially. Now check the result. Now what happened right previously? Super class constructor is called for super class object. Here, super class constructor is called, and then subclass constructor is executed sequentially. Hope you understand from these examples.
Sir, can we
Rectangle R1 is equal to new rectangle. What one?
sir, can we use the super keyword to initialize the constant instance variables of a particular class, sir?
Super to initialize initialization is not permitted, but in case if you want to redefine right the instance variables, those are hidden. That stage you can use super dot super class instance variable. That is instance variable hiding. You wait for right few pregnants, we will be seeing how the superclass instance variable is given. So as of now, right, let me repeat again, 2.5 comma 0.9f, no problem. Rectangle class constructor, control goes to call rectangle class constructor, in which rectangle, that is subclass constructors statements are executed in the sequential order. There is no doubt in that. But since super of X is introduced, before executing further statements in the subclass constructor, we are saying that control goes to call the superclass constructor because super of X is introduced. So control is transferring to execute the superclass constructor by passing the value of X. So it seems that the value of X is received here. You can see the message superclass constructor is called, and then control comes back, right, to execute the sequential statements following the super statement. This is very important. Control is automatically coming back to execute the statements which are following the super statements, super statement, right? So only one time, right, you try to use the super statement. So subclass constructor is executed sequentially, right? Then R is equal to Y is taken place.
Sir, once explain that rectangle single parameter, single int, single float. Once again.
This one, okay, yeah, 1 minute. Let us give the same message. Rectangle here, super X. Following this, I am giving subclass constructor one parameter. Here, subclass constructor with two parameters. Subclass constructor is executed sequentially. Here also, superclass constructor is called. Okay, no problem. Now have a look into right at this output. Here right a superclass constructor is called. Subclass constructor with two parameters is executed sequentially. Then the second run right superclass constructor is called. Subclass constructor with one parameter is executed sequentially. How it was the second time new rectangular 5.0 simply this invokes rectangle class constructor. There is no doubt. So rectangle class constructor with one parameter. One parameter is defined here. Where is it? Here. Yeah. In which the statements are executed in the sequential order. Since super of X is used, control goes to call the superclass constructor first. If super of X is not used, no problem. Then we can see the message. Subclass constructor with one parameter is executed sequentially. This is the first executable statement. Because of super of X, the value of X is passed as a parameter to the superclass constructor. You can see the message, a superclass constructor is called. After this, control comes back to execute the next sequential statement, this one. Subclass constructor with one parameter is executed sequentially. And then the sequential execution is going to be taken place. Clear?
Yes, sir. Yes, sir.
Okay, the next example, inheritance 5. We try to write complete overriding with respect to the instance variable and methods, right? Method overriding, right? With initialization. Instance variable hiding in Java, right? One of you asked, is there any possibility to initialize the instance variable using a super? That is not possible. That is not an initialization. The usage is somewhat different. When you have the same
Sir, I
instance
asked about
variable, both in yes,
Sir, I asked when we are having a constant instance variables in the class A, sir, and if we want to initialize those constant instance variables through constructors, then can we use the super class? I'm asking.
yeah, that is possible. So you mean int x in class constructor A, you do want to initialize x is equal to 10. Am I right?
No, sir. Actually, in class A, I'm having a instance variable as constant x, sir, and I want to initialize this constant int x through constructor, sir.
Yeah, because const int that is not supported in Java, it must
Final,
be a
final.
final input. Yeah, it must be a final int. When you declare a variable final, you must provide the initial value.
Sir, as you said in last class, final can't be redeclare. That means the value cannot be rechanged, no, sir. Once if we declare final, it can't be changed, no, sir.
Yeah, it cannot be rechanged. But here, write a final int x is equal to 25. In case if it is an instance variable, in the declaration itself, we have to use the final int x is equal to 25. Further, right, the variable x cannot be redefined in the constructor of class C. Not possible. Final variables cannot be redefined.
Actually, in C++, we can initialize those constant int x with in constructors with that initializer list, no, sir. So, do we have any alternative method in Java? Like, I'm asking.
I think no alternative method. As far as final variables are concerned, it must be initialized in the declaration statement itself. If not, inside the constructor, you can declare a variable as final. Final int x is equal to. You try to do that way. What I am saying, class A, in constructor of A, say for example, integer A, try to pass that value A to the final integer variable in the constructor of class A. You try to check that if it is possible, but anyhow, that will be a local variable, local final variable to the constructor of class A. Local variable, right, again cannot be inherited, right, in inheritance, and even though that local variable cannot be accessible outside the scope of that constructor definition. So here, right, is the second usage of super keyword. First usage of super keyword is to call the superclass constructor from the subclass constructor definition. That super must be the first executable statement. Second usage is like that whenever both the super and the subclasses are of having same instance variable, what will happen means the subclass instance variable overrides the version available in the superclass. A simple example, int x is equal to 10. Inside the method, we have printed the variable x. X is equal to right x. Then class B extends A, a simple inheritance is applied. The integer variable x is set to 25. Now what happens means, what is the logic of inheritance? Code reusability. Code reusability. The highlighted code is again available inside the class B, but we have already discussed that once a variable is declared, the same variable should not be redeclared, right, with respect to a block scope, right? But however, in inheritance, like method overriding, instance variable overriding, right? Or instance variable hiding, that is possible. So int x is equal to 10, declaring the same variable, right, inside the class B. Now what will happen? The scope of x, right, this x is equal to 25, actually hiding the actually hiding the instance variable x available in class B. So this x hides the x in superclass. Now another thing, right? I have used the same method. Of course, this is an example of a method overriding. Void method. So what happens? Same type signature is there. Return type method name parameter list. Return type method name parameter list. And the same type signature is available both in super and subclasses. Method overriding will be taken place. So here class B X is printed. Then in case if you want to access the superclass hidden variable in the subclass method, you need to use super.x. Hope you understand. Super.x accesses the actual value of a superclass instance variable, assuming that x is only hidden, right? In other cases, right, no need to use super dot something, right? The variable is automatically available in the subclass. So to call the superclass instance variable inside the subclass method, when the variable is hidden, you need to use the super keyword. Usage is super dot instance variable, right? Likewise, if you call a method, right? Method here, actual method available in the super class. Inside the subclass method, we have to use a super keyword. The usage is super dot method. Super dot method makes a method call to the superclass method when the method is overridden in the subclass. So the object of class B is created, then B dot method is called. Have a look into right what is actually done in B dot method. B dot method. Hope you understand. A dot method, right? The method is available here. Same type signature is available here. Void method. So using the object of class B, the overridden method is called. Now what happens means the method which is available in the superclass is overridden, right? Superclass method will not be called using B dot method. So B dot method simply calls the overridden version or this highlighted version overrides the version available in the superclass. So we can see the message class BX, right? Let us check it. Java inheritance 5. What happens? Java C inheritance 5 dot Java. Java inheritance 5. Have a look into right the order. B dot method. B dot method calls actual version available in the subclass because same version, right? As same type signature is available. This version actually hidden in the subclass. So class B is X value. Class B is X value, right? Again, X is 25, but here X is also available in the superclass, but X is also hidden inside the subclass. So X is 25. In case if you want to access the actual value of hidden variable X in the superclass means use this general form super dot X. Super dot X means right it prints a value 10. 10 is defined in the superclass. Accessing class A overridden method using super to access that call super dot method. Simply it calls the superclass method, then class A X is equal to X. When executing class A X is equal to X means this value is taken X is equal to 10. Of course, we have introduced right to two things. One is instance variable hiding, and another one is method overriding. And how to resolve the method overriding with respect to call of superclass method, or how to call the superclass instance variable to resolve it from hiding in the actual subclass. We have to use the super keyboard. The second usage of super keyboard is this one, super dot instance variable, right? This will be introduced in the method of a subclass definition. Super dot method name can be introduced in or accessed in the method of a subclass definition. Understand? Having any queries in this?
Sir, if we write a dot method, will the method in the class A will be invoked, sir?
Yeah, that's what in the last class I have said. Here class A is being a superclass for a subclass. This does not mean that the superclass methods cannot be used by the object of A. That means superclass methods can be independently accessible using its own object. So A dot say A obj, assuming that A obj is an object of class A obj can access its own members A obj dot x, A obj dot method. That is valid. So two possible
Sir,
usages
here
of
A is
super
not an
keyword.
abstract class, sir.
Pardon?
A is not an
Pardon?
abstract class, no, sir.
Yes, A is not an abstract
A is
class.
not an ab
Yes, A is not an abstract class. To make the class as an abstract
Thank
one,
you, sir.
we need to use the keyword abstract. Of course, right at the end of inheritance, we will be focusing on abstract class. Abstract classes are also helpful in achieving runtime polymorphism. The second possibility, Java to achieve a runtime polymorphism is with the help of abstract classes. I think tomorrow, right, we will be completing right the runtime polymorphism and abstract classes. So anyhow, right, let us see, try to some more. concepts. Multi-level inheritance in Java. Java directly does not support multiple inheritance. Acquiring the properties from two or superclasses, not possible. But later, right after this, right, we will focus on packages and interfaces. Using interface concept, we can achieve multiple inheritance indirectly in Java. So just to think of multi-level inheritance. Class A, one method is defined void method A. Class B extends class A, right? So this is level 1 inheritance. Class A to class B. Method B is defined. We are given the message inside class B. Then class B is further extended into a new class, say class C. Class C extends B. This is level 2 inheritance. We are provided the additional method, say void method C. Now what is the concept? Void method A is automatically available in class B because of simple inheritance. Void method A and void method B. Both methods are available in class C because B is extended from A and C is extended from B. So all of these three methods, method A, method B, method C, are actually available in class. Method C is additional member of class C. Other than that, method B and method A are actually inherited from A and B, right, into C. Now, using the objects of the independent classes, you can access its own methods, right? And using the object of the acquired properties, you can access the relevant superclass methods. So, using the object of A dot method A is valid. Object A can access method A. So you can see the message inside class A, right, as the first line of code. Then B dot method A, B dot method B, these are valid. So since B is an object of class B and the method A, which is inherited, tried into class B, the features are tried into class B. So using the object of B object dot method A, B object dot method B is possible. Then third level, sorry, that is the second level right here. Class C extends B. Class B, right, takes one method B and one additional feature taken from method A. Both of these features of B, right, are actually inherited into class C. So C object can have the rights to call the three methods: method A, method B, and method C. Java inheritance says 6. Java C.
Sir, Java C.
Okay, Java C inheritance 6 dot Java. Okay, I think I have not compiled the code already. So okay, then Java inheritance 6. Inside class A, then inside class A B, class A B. Then for the third object call, the result is inside class A, class B, class C. This is the multi-level inheritance. More than one level is possible in Java.
Sir, is there any possibility of ambiguity, sir, when the class A and class B have the overridden functions?
No ambiguity. You're asking as you did in C++ language. Class A to B, right?
Yes,
One
sir.
version from A to B, and you just think of A to C, one version from A to C, and then right deriving the
Yes, sir.
features from B and C. B and
Yes,
C,
sir.
in that case, multiple features from different parents. So there can be an ambiguity. The two versions can be there from B and C into T. Here, right, directly multiple inheritance is not supported. So no ambiguity will be raised. Then seventh one, we see right the node program. How constructors are called right in inheritance. Class X takes its own constructor. Class Y, right, which is extended from class X. Class Y takes its own constructor, right? All are one argument constructors. Class Z, which is extended from Y, and which defines, right, one more constructor. Now the thing is, we are creating an object of z. Z object is equal to new z. That's all, right? So in that stage, what will happen? We are constructing an object of class z, right? We are constructing an object of class z. So constructor of z is going to be called, but z is an inheritance chain, right? Z is extended from y. So and further, right, y is extended from class x, right? So it seems that the constructors are called in what order the classes are constructed, right? First class x is constructed, then y is constructed, then z is constructed. So you can find that in that order the constructors are called. First class, then second class, and the third class. Java inheritance inside x, inside y, inside z. Same as that of C++. In what order the constructors are defined, in that order constructors are called. In case if we create an object of y, y object is equal to new y. What happens since y is capital Y is constructed from the class x. So ultimately class x constructor is called first, and then class y constructor is called y space y, not y. Inside x, y is z, right? It corresponds to this line. Creation of object is z, small z. Then creating an object small y, right? What happened? Y is extended from class x, so x constructor is called first, and then y's constructor is called. In that order, objects are constructed, right? In what order the classes are constructed. Having any queries? If you have any queries, you can ask.
So once can you explain about that ambiguity again? Like I'm not confused.
Which ambiguity?
The multiple inheritance, or multi-level inheritance in Java. When the class X is having a same method, and when class Y which is derived from class X is also having the same method, and class Z which is derived from class Y, and the class Z wants to call the method of class X. So how it is possible? It will be having an
But
ambiguity
clearly,
between these two.
your voice is breaking.
Sir, am I audible now, sir?
Yeah, clearly.
Sir, when class X is there, sir, class X is having a method A, sir, and even class Y, which is inherited from class X, is also having the same method, sir. That is, both the
One
methods are
minute,
overridden.
yeah. 1 minute. Say class X. What you have to do in class X?
Is having some method, sir. Suppose
Okay. Let it be void. Uh, then
then class Y,
class
which is
Y
extends class X.
extends X.
X.
Okay, then
It is having also the same method void up. This is a overridden method.
okay. Yeah, overridden method. Then
And class Z, sir, which is extending from Y.
class Z extends
Y.
Y. Okay.
Now I want to call the method of X from class Z.
Tell me, you want to call the
Method of X from class Z, sir.
in which class?
After creating the object of class Z, I want to call its method, sir.
Okay, say z object is created is equal to new z.
Sir, this void f is not there in the Z, sir.
Void f is
Not there in class Z.
not is it okay, not in is it okay, no problem. Some other methods are there. Yeah, tell me.
Yes, sir. Now I'm calling the Z dot void f. Z dot f. Z object
Z
dot f I'm
dot,
calling.
yeah, good question. Z dot f,
Yes, sir.
which is available in the class X. Okay, since f is also available, but here if you call, good question. Z obj dot f. What happens means this actually calls f in which class? Y. If you want to make a call, am I right?
Yes, sir.
Yes or no?
What, sir?
How can you call?
Yes, sir.
Yeah, how can we call f in X?
Yes, sir.
Okay, this is your question. Can anyone answer this question? Is that obj dot f? Actually, it should call a version which is available in class X.
The calling Z obj dot f, won't it shows any error of ambiguity, sir?
It will not show any ambiguity because here we are not inheriting the features from multiple classes. We just think of class X f is there. This highlighted version is actually available in class Y. Okay, so indirectly it seems that this highlighted version is available in class Y. So including the highlighted version available in class Y, additionally the same version is available. You just think of this only void f. This is said to be a type signature in Java. Return type, method name, parameter list. Since both of these are right available here, method overriding is taken place.
Yes, sir.
Method overriding means this version will not be available in class Y. So calling isobj.f means the actual version available in class Y is taken. Since method overriding is implemented, F's version of the class X is not available. But here there is another possibility, right? We can't directly call isobj.f to have the direct call of the F which is available in class X. But indirectly, for example, inside this method, if we introduce super.f means, let me write here, super.f means, this may call or this actually calls, right? This statement calls the version available in the superclass. So one possible solution, this will not directly call the version available in the superclass X. It's not possible because of we have overridden in the class Y. But one solution, we can provide super.f like this. If not, you can define some other method, say void g, in which super.f is introduced to try to call isobj.g. That is the other solution.
Sir, if we are having class Z extends y comma x, sir.
Not possible
It
because
is
in Java
it is
when
not possible,
using
sir.
not possible
Why, sir?
because this is a simple inheritance, right? Multiple inheritance is not directly supported. You cannot provide right multiple classes. Extends super class 1 comma super class 2. Java does not support multiple inheritance directly. So in that
Okay.
stage, we need some alternative concept interfaces. So you can define right a class
Yes,
is
sir.
extends y, then implements another interface. And later you see interfaces are similar to classes, right? But they make instance variables. Methods definitions are there, declarations are there, and a method must be redefined in the implemented class. So that stage, right, you will realize that class Z, right, can be extending the features from class Y and implementing the features of interface some I1. So it seems that similar to the top, deriving the features from two different superclasses.
Sir, if we are having the same function void
And
f in class Z, then the Z f function will be called, sir, in class Z. If we are having a
what
void,
on void f in class Z,
yes, sir.
void f in class Z. So
Yes, sir.
in that case, right, what will happen means, yeah, Z version is going to be called Z obj.f means this is not commented out. Calls version available in Z because this is this one to this one overriding. and from this one to this one, complete overriding. So Z class
Sir,
version is called.
sir, again, if we write void f and if we write super dot f, then which version will be called, sir? Y version, sir. In
That
class
you
date,
need to check out, right? I have not checked it. So that's what I say, that you need to check out. Because here inside this F, right, a super, if you try to use super dot F, right, actually this calls the version available in this super class. So sure, right, it may give the versions available in the class Y. Y's F version is called. And if you want to call the class X a person, as we discussed earlier, you need to define some other method that introduce super.f, and that method should be called inside the class user. That is the only resolution. Okay, having any other queries, you try to check this calling the super right from z into y and from y into z. Try to write a code and check it and verify the results. Okay, thank you very much. Tomorrow, right, we will complete the remaining topics, and probably we will complete right up to the abstract classes, so that the inheritance will be over by tomorrow. Okay, thank you very much.
thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.